All right, thanks, Ashley. Welcome, everyone. So the premise for today is based off of a lot of questions that we've been getting over the last few months from some of our customers that are trying to do some animation in Inventor with their assemblies, and sometimes things don't go as planned, and they've been asking us if 3D Studio Max will get them to their goal. And so we're here to answer some of those questions today, and we've got a good example for you. So let's go ahead and get started. So what we have here is a sample assembly from Inventor. So we will spend a little bit of time in Inventor just doing some preliminary setup work. So we won't be working with constraints or anything deep in the assembly. All we're going to do is focus on a good level of detail, because we don't want to bring in every nut and bolt of our assembly. We only want to bring in what we want to see. And then we're also going to set up the materials. And that's about it for Inventor. We're going to spend most of our time in Max. And once we import the assembly into Max, we'll take a look at some of the key settings. That way you can have sort of a template methodology when you are bringing your Inventor assembly in. That way, once you import it, you can get right to work. Once we have it in, we'll take a look at how to position the components in the assembly, work with the materials. I'll show you a little bit about the environment in Max and to help you with the basics, and then we'll do a short animation. And the animation we're going to do today is something a little different. Normally when we see manufacturers working with Max, they're moving components from point A to point B, or maybe something appearing and disappearing, that sort of thing. Today we're going to look at rotation. And the reason I chose that particular motion is because there is a little gotcha when you are trying to rotate something in Max. And I wanted to show that to you because things don't always go the way we want, and things don't always go the way that you've seen in a webcast. So I thought I'd share that with you. That way, when it does happen to those of you who try this, you'll know exactly how to get around it. Okay, so first we're going to hop into Inventor and take a look at the assembly that we're going to use today. This is a pretty simple one. It's got 3 sub-assemblies. We've got a top section, a bottom section, and then there is a base support with a rod running up the middle. And what we're going to do in Max is we're going to make the upper and lower sections here rotate in opposite directions. And that's where we'll show you the gotcha when we get there. So on the Inventor side, we are assuming the assembly is built. You've done your bill of materials, your drawings, all of that part of the design is done. Now we just want to prepare it for use in Max. So the first thing we're going to do is just look for what we don't want to bring into Max. And in this assembly, it is quite simple. So what we're going to do is remove the screws that you see in the upper and lower areas just to go through the steps for setting up your level of detail. Now those of you that have done this before, this may seem rudimentary, so I am going to keep this basic just to go through the overall workflow. So step 1 here, we're going to create a new level of detail. And you can name it whatever you want. I'm just going to name it no screws. And then all I'm going to do is go around and pick these screws. There aren't too many, so I am doing this the old-fashioned way. No special method here. And once I get these selected, then I will suppress them. So the main reason here is if your assembly has a lot of internal parts, you've got gears, motors, wires, etc., and if they are not visible from the outside and your goal is not for them to be seen anyway, it's a good idea to set your level of detail accordingly so that you're only importing into Max the minimum amount of geometry that you need. And that'll cut down on your import and your processing times. So we'll take care of that. And then next we will set up the materials for each of the components. So first I'm going to select these two bases here. And by the way, I am working with part priority. So if you hold down the Shift key and right click your mouse here, you can change how you are selecting your parts in Inventor. So you want part priority right now. And I'm going to select these two bases here. And I see up in the materials list that it's already got a material assigned, but over to the right it doesn't have an appearance assigned yet. And that's what we're going to set now. The material in Inventor contains all of the physical properties for that material. The appearance is what Max will pay attention to make these components look the way you want. So we'll go ahead and set a appearance for this part here. And there is a wood down in here I'd like to use. We use the white oak. All right, so that takes care of those. Next, I'll select this cap on top here, and then the support bar. And you can use the control key to add to your selection here. So we'll get those selected. Again, this has a material assigned, but no appearance. So we'll set that, and I'm going to choose chrome for this one. We'll choose that polished chrome and give it a nice shiny look. It does look okay in Inventor, or look the way it should anyway. And then next, this will take a few moments. I'll need to select the rest of the components here, since I'm still on part priority. And I want to make all of these the same material. And it's important to take your time during an operation like this because you don't want to lose your selection and have to start over. So make sure you do use the control key and take your time. Got that one, and we'll do a quick orbit to make sure I didn't miss anything on the back side. Looks like I missed one there, so we'll grab that too. All right, so once you have those selected, I can see here that those components also have a stainless steel material, but no appearance. So let's give it an appearance. Also, when you are browsing in these two lists, you can press a key on the keyboard and help you sort alphabetically. So if I want to jump down to the S's in this list, I can just press S, and at least it will jump down there and cut down on the hunting and pecking that you have to do in this list. So for this appearance, I'm going to use steel blue. So it's still the steel appearance, but it's got a blue tint to it, just to do something a little different. On the bottom, this is a judgment call. Usually when we are animating things in Max from an Inventor assembly, if you're not going to see underneath your assembly, then there's really no reason to set the appearances for those components. But just in case, if you want to be thorough, then we'll go ahead and do that. So what I'll do here is select these three components here. Those already have a material like the others, but no appearance. And since it's rubber material, we'll give it a rubber appearance. And then in Max, if we decide to shoot the scene from underneath, then we will have taken care of that. This piece here already has an appearance applied to it, and so we can just leave that alone. Okay, so that takes care of the materials. And that's all we're going to do here. We're going to do the rest in Max.
Brett, I have one question for you. And it's, is a level of detail required, or will a view representation work with the same functionality?
That's a good question. And quite frankly, I've always done a level of detail. That's just been my habit. And so I will be honest with you and say I'm not sure if that will hurt or help. So that's something that we would have to do by trial and error. But I do know that just doing level of detail and either setting the visibility or suppressing the necessary components, that does work. And so, I just stick with the method that's always worked for me. So that one you'll have to try if you're going to do a view representation. All right, so I hope that answers that question. If not, then we could address that after the webcast, and I'll see what I can do for you. Okay, so we're getting ready to save here. We do want to make sure that our new level of detail is the active one. And here I'm going to do a save as. All right, and once it's saved, we're ready to switch to Max. So over in Max, I went ahead and did a little bit of setup work ahead of time. All I did was set my scene the way I want. I just have a plane sitting here, a surface that will let my assembly have something to sit or stand on when it comes in. And then we also have an environment setting just to help with some simple lighting. We are keeping this as simple as possible today, not doing any major movie work. And so all I want to make sure is that we have some light, it looks natural, and I want to be able to move on to the assembly. To make the environment possible in Max, you can use the type of image that's known as an HDR image. These are available across the internet. And they are the types of images that have light information embedded in them, which is another way that we can light our scene here without having to add a bunch of lights manually. So it works great for when we are bringing Inventor assemblies into Max. So that's already been set up. So step one in Inventor is, in Max is to just import your assembly. So we'll go over to the File menu and down to Import. We'll choose our assembly, and we only need to choose the top level assembly. And then we'll be prompted for some settings. So whenever you bring in an assembly from Inventor, you'll get this dialog, and you can set it up exactly like you see here if you want. These are some very common settings that anyone can use. We're bringing in the geometry as body objects, and that will allow them to behave just like they do in Inventor. If there's any duplicate parts, we don't want to have those replicated as a geometry in Max, so we will reference duplicate parts instead of create new geometry. We can import driving animations, so if you have driven any of your constraints in Inventor, you can import that into Max. But there is a limit though. You can only bring in one of those driving animations at a time. And so that's one of the main reasons that we bring it over to Max, because then that restraint is lifted. We're going to add our own animations here in Max. And most definitely, we want to import Inventor materials. So this is a box that you'll want to check and then leave checked forever. And if we were to import driving animations, then you'll check that box there. And then you can bring in your joints or your constraints. That depends on which ones you have driven. Of course, we haven't done any of those in this assembly, so this list is empty. So there's no reason to check that box. So from one assembly to the next, your settings won't change a whole lot, which means you, as soon as this dialog comes up, you'll be able to just click OK and start the import. Now this assembly is a pretty simple one. It doesn't have a lot of components. It'll take about 10 to 20 seconds to import. And this is where the level of detail is important. If you have an assembly with lots of parts, then how you set that will determine how long it takes to import. All right, and here is our assembly as it appears in Max. It looks quite the same. All right. So we're going to work on the animation first today. So we'll get right to that. And then after we do that, we will circle back and focus on the materials, because we want to make sure that all those appearances that we set in Inventor are going to show the same in Max. We only want to have to do that once. And since we've already done it, then we want to make sure. But we're going to animate first. So what we're going to do is we're going to have the lower section here rotate 360 degrees in one direction, and then we'll have the upper one rotate in the other direction. Over here in the Scene Explorer, this is comparable to the model tree in Inventor. If we expand on this, notice that there's one single item here. So what Max does is it groups the assemblies and the sub-assemblies. So it maintains that hierarchy, it just doesn't call it an assembly here. So when I select it out in the view here, the entire assembly is selected as one object. So in order to operate on this and animate each of the tiers here separately, then I have to peel back the onion a little bit. So what I'm going to do here is select on the top level group here and come up to the group menu and ungroup it. So we're just going to ungroup the top level assembly, and that will allow me to select each of the three sub-assemblies individually. Now we don't want to ungroup any deeper than that, because then we'll wind up with a lot more items in the Scene Explorer here. It'll become a little bit more cumbersome to find what we want in order to work on it. So we're going to keep it grouped at the sub-assembly level. All right, so that's the first thing there, just looking at the Scene Explorer. Next, we're going to set up for the animation. And if you've animated anything in Inventor, one of the first things we need to do is do our time configuration, set up how long we want the animation to be, and so forth. And we'll do the same thing in Max. So I'm going to come down here to the bottom of the screen and go to Time Configuration. This button is right below the playback tools. And Max likes to work in terms of frames. And so I can go with the default settings here. And I'm going to set this up to be about a 10-second animation. And if I'm going with the default frames per second here at 30, then that means I need 300 frames. So under the animation section here, you'll want to set your end time to the total number of frames that you want available to you. So 300 frames at 30 frames per second will give us a 10-second animation. So we'll set the end time right here and click OK. And now as you see along the timeline here, we've got a total of 300 frames to work with. As you move the slider bar, nothing is happening right now since we haven't told the geometry to do anything yet, but this is how we can manually manipulate once we start assigning some behaviors here. So to start with our animation, the first thing you want to do is make sure that your slider is on frame 0. You just push that all the way to the left, and then come over here to the right side of the animation tools, and we're going to activate auto key mode. So we'll click on the auto button. That's going to turn your timeline red, and that's how you know you are in auto mode. And when that is active, whatever you do, whether it be move, rotate, make something vanish or appear or scale, whatever we do is going to be captured at the frame where the slider is sitting. So since we want to do a 360-degree rotation, we don't want anything to happen at frame 0. So we'll take the slider and drag it all the way to the other end to frame 300. And then we'll select the lower tier. And then we'll activate the rotate command. And then we'll rotate along the Z-axis. All 3 axes are available on the gizmo. We can also come down to the X, Y, and Z value boxes here and set a degree angle here manually if we want. Right now I'm just going to click on the Z-axis, which is the yellow one, and I'm just going to drag it like so. So either method will work. And I'm not going to come all the way to 360. The reason for that is because when we're rotating, if you set 360 as your destination angle, then it will immediately be interpreted as 0. That's just something that Max does. It won't hurt anything because I'm going to show you how to modify that afterward. Right now, I just want to drag it out. I'm watching the blue highlight that's inside the rotation gizmo, and I'm going to come out to almost 360 and let go. Now, if we look down on the Z value right here, you can see that it recalculated that, and it's not the angle I would have expected. All right. Now, on the slider bar, as we drag that, now we can see that it is rotating. It's starting at 0 degrees at frame 0. And as you drag the slider bar to the other end, it's rotating close to 360 degrees. Now, I want to make sure that is a true 360 degrees. So what I'm going to do now is I'm going to edit this little key that is on frame 300. It's kind of hard to see. It's a little green key that's sitting at frame 300. And you'll be able to select it. Just as you hover over it, your cursor will change into a plus. That's how you know that you're hovering on a key. And I'm going to right-click on that key and then choose the Z rotation value for that key. So when we do this, we can edit this value and make it whatever we want. So this one I'm going to set to 360. That's all I'm going to do. So now, from 0 to 300, you get a full 360 degree rotation. So that takes care of the lower tier. So we'll make sure that our slider is on frame 300 again, and we're going to repeat this for the upper tier with one small change, which you'll see in a moment. So here we'll drag on the Z axis to give it some rotation, and then we'll go back to the key for this object that is on frame 300. We'll right click and again go to the Z rotation. This one we're going to set the value to be minus 360. The reason I'm doing that is just to illustrate that we can have the bottom tier rotate one direction and the upper tier rotate the opposite direction. And so now we should have a behavior that looks like this. So we got the directions working, but there seems to be a problem. And this is what I mentioned earlier about the gotcha that you'll get from an Inventor assembly. If you can look at that top tier, it's rotating in the direction we told it to, but it is not rotating about its center axis, which means that when you bring in an Inventor assembly, the constraints in the assembly are not considered when it's brought into Max. All that's brought in is the snapshot or the last position of those components when the assembly was saved. All right, and that's the next thing we're going to take care of. So that's the gotcha. We are done with our keys and our animating though. So we are going to turn off auto key mode. I'll go ahead and set the slider bar back to 0. And then we'll go to work on the pivot points for the top and bottom tier. To do that, I like to work in a top view. And I'm also going to set to wireframe display just to make it easier to see, as well as an orthographic projection there. All right, so we'll zoom in. We're looking at this from the top now, and if we were to drag the slider bar, we can clearly see that those are not behaving themselves. They are rotating, but that's the only thing they're doing. So we need to take care of that. All right, to do that, we want to make sure we have a couple of settings in place to help us out. The first one is the reference coordinate system, and that's this dialog right here. You want to make sure that that is set to view. That's all you need to know. the button just to the right of that. We want to make sure that this button is set to use pivot point center. And if I click and hold on this button, there are other center points. There's one based off of the whole selection. Remember, this is a sub-assembly, so there are other components, and Max may not magically know that you want one rotation point over another because of all the components. So it's kind of like it tries to find the center of the sub-assembly, whereas what we want is that axis down the middle. So we want to make sure that we choose this top button here, which is called Use Pivot Point Center. And that's going to allow us to adjust the pivot point for those two assemblies. So make sure you're set to View on the reference coordinate system and Use Pivot Point Center. Over in the Scene Explorer, I'm going to use that to select one of the sub-assemblies. And then over on the right side of the screen is where we go for all of our commands in Max. Usually when we're creating objects or modifying objects, we use the command panel that's on the right side of the screen. The panel that we want to use in order to adjust the pivot point is the third one over. It's called the Hierarchy panel. And then the command we're going to use is Affect Pivot Only. And what that allows us to do is only move the pivot point for the subassembly or the group instead of the group itself. This is a nice little trick to be able to adjust this without pulling the assembly apart. So we'll do Affect Pivot Only. When you do that, you will see your gizmo change its appearance. And then we can move just the pivot point to be in the center of the components. I'm also going to turn on my 3D snaps, which is this button right here, and that will allow me to snap to the center there, which is actually a grid intersection. So we'll turn on the Move command with our 3D snaps. We've got Affect Pivot Only activated over here, and now we can drag the pivot point and snap it in the center of the objects. That's where it should be in the first place, but as we saw when we set up our animation, we haven't told Max to constrain that subassembly. So this is how you can constrain your geometry in Max if you were to compare it to Inventor. So if you're thinking constraints in Inventor, then think about your pivot points when you're in Max. Once that's in place, we're going to deactivate the Affect Pivot Only, and then we'll drag the slider bar to test it. And if I'll go a little slower, one of them is still out of position, but as you can see, this one now rotates about its center. All right, so now let's repeat that for the other one. So we'll choose the lower tier, and as we can clearly see here, its pivot point is off center. So we'll go to Affect Pivot Only. We'll make sure Move is turned on, and we'll drag this and snap it where it needs to be. And then deactivate Affect Pivot Only. Make sure that you turn that button off when you're done with it. Okay. We're also done with our 3D snaps, so I can deactivate that. And then I like to drag the slider bar. You'll see me do this quite a bit. We'll make one change, and then I'll test it by dragging the slider bar. So now we can clearly see that we have good rotation for both the upper and lower sections. All right, we'll take this back to our home view and turn our shading back on. I'm feeling pretty good about this rotation right now, so I'm going to use the playback tools here and I'm just going to play the animation. I can see that there is a slight increase in the speed, and then it'll decrease slowly towards the end of the animation. And Max is set to loop by default. If you don't want that, you don't have to do it that way. But if you want to keep watching it, then Max made that the default. And it looks pretty good. So the animation is set up. Now let's focus on the appearances. We haven't done the materials yet. We did some work on those in Inventor, and we want to make sure that they are working here in Max. They look good from a bird's eye view, but that doesn't mean that they're going to look realistic when we're ready to render these for your customer or whoever. So what I like to do when I start working on the materials is go ahead and just hit the render button and see what I'm dealing with. As you can see here, it is rendering, but I'm getting some errors. And the reason I'm getting those is because the renderer that comes with Max is known as the Arnold renderer. It is a new one that came out in 2018, but the materials that we've been used to using over the years aren't supported in Arnold. And that's what I'm being told here, so I do have to do something about that. But these are Autodesk materials, and they're still applied to those objects. So we haven't lost them yet. We just need to make them compatible with this new renderer. To do that, so this would be step 2. Step 1 would be your animation. Step 2 is to convert your materials. So let's go to the rendering menu and then the scene converter. This tool will convert the materials from wherever they came from into materials that are compatible with the Arnold renderer. And I am using a preset here, so this is something that we can save and reuse from one project to the next. And if we look at the material settings here, what this is telling us is that whatever type of material we've applied in our assembly will be converted to a physical material. That's all that happens. It doesn't change the images that are used. So if you have custom images for your products, it won't change those. It just makes them physical materials that will play nice with the Arnold renderer. So all we have to do is convert the scene. And then we'll render again and see what we're dealing with. So this time, it looks like it's improved right off the bat. There's no errors now, so all the materials are supported, and they also are starting to look more like the real thing. You can see some reflections and so forth. But we're not quite done yet. That was kind of a low quality render there, but right now all we're doing is looking at the materials and making sure that we don't have errors and things like that. All right. So before we go any further, let's set up a camera to make this look even more realistic. So I'm going to switch to a 4-view screen here. I like to use a top view when I am adding cameras. And that's the next step when you're setting up to render or produce your animation. So over in the command panel, I'm going to choose the create panel, which is the first one. And then the fourth button over is your cameras. And there's plenty to choose from. And this is a point where we can stick with the standard cameras that come with Max. There is an Arnold camera, but that is mostly when you want to set up for doing virtual reality, or you're going to look at it in goggles or 360-degree panoramas, things like that. Right now, we're just going to stick with standard, and we're going to use a physical camera. So we'll place the camera in its target point, like so. And since I've got 4 views up here, I'm going to work with these for a minute. I'm going to set this view down here to be that camera view. So now we can see what the camera is looking at. And then when you select the camera in one of the other views, now I can work with it to position it. And as I start changing the position of that camera, you'll see the view that's set up will react naturally until I've got this place where I want it. So I'll do some positioning here. I can also change the target point of that camera. I'll do that by choosing it from the Scene Explorer here. So if you want to point the camera in a different spot, then you can do that as well as position the camera itself. So we'll kind of back this up and lower it and get everything in view. target down. There we go. So something like that. So you position your camera. Then we're going to switch back to a full screen view. And then let's do another test render. So once we add a camera view, now we are going to start getting effects for things like exposure and other results that you would get from an actual camera. And that's what really helps to make these assemblies look more realistic since we're using a physical camera with physical materials and we're using the Arnold renderer. So that takes care of that. The materials are set up from Inventor. We could stop right here and we wouldn't have to do anything else. The next thing we would do is focus on the quality. I've got it set pretty low right now just so we can render quickly and make sure that things are working. And I also don't want you all to have to wait for these renders right now. So that's what we'll do next. Before we do that though, I want to pose a question to everyone, which is, what if you bring an assembly into Max and it doesn't have any materials applied? And maybe you're not the Inventor user. So you can't go to Inventor and you can't apply the materials there and import them with the rest. So how do we do that? How do we apply materials here in Max? So we'll just work with this one the way it is. There's no need to re-import. And since we're using the Arnold renderer, let's open up the material editor. The material editor is used for applying the materials manually and changing their properties and how they're going to look, if they're going to have reflections and things like that. The materials that you see here under the scene materials, these are all the materials that came with the Inventor assembly. As you can see here, this little red colored area for each of the materials means that that material is visible in the scene. That's all that means, but it's a good indicator to have on your scene materials. But I want to point out something here with the Arnold renderer. I'm going to collapse all the branches here. If you notice here on the Inventor side, there was a library called the Autodesk Material Library. The Arnold renderer does not have that library available, which could be a problem. If you're used to working in Inventor and you need a material, it's going to be hard to find. So that's the first thing. So the alternative to that is to use a physical material. So if you expand on materials under General and double click on Material, and that will add it out to the canvas here, and then we can set the properties. And there's a really slick way to do that for those of us that don't want to become professional material users. Just double click on the material. We'll give it a name. So say I was going to apply a new material to the bases. So I'll just call it the base material. And then with the physical material, you can choose from one of the presets. And there are plenty to choose from. And there's some woods, some plastics, some concretes, there's plenty of metals. And these already have presets for all the properties that are common to those materials. So for example, if I wanted to use a satin varnished wood, I'll just choose that. And the material editor does the rest. It brings in, if there's a clear coat, if it has any glossy, the finishes here. There's a bitmap here for the wood image. Things like that. I will make sure that this is visible in the scene, so I'll select the base material here, and up in the toolbar for the material editor, you'll choose Show Shaded Material in Viewport. And that gives it the red indicator, and so that way we'll know that it is visible when we apply it. So we'll set up the base material, and I could do other materials for the metal if I wanted, but those are already in place. So we'll just change one of these to save some time here. And I'm going to change the material for these two bases. Now to do that, I am going to have to get inside these groups, because remember, the sub-assemblies are grouped, And so we'll have to open these groups in order to work on the individual parts that are inside them. So it still behaves like a subassembly. So I'll pick the top one and come up to the group, drop down, and open it. All right, and you'll see me move the material editor around a little bit so I can keep it open at the same time. So now I'm inside the upper group here. You can select on that object in the view. Notice over in the modify panel is the name of that component. That is from the Inventor assembly. Over in the Scene Explorer, you'll see it in the list there as well. So there's plenty of places where you can reference and know what you're looking at. So for that upper wood base, we've got that selected. In the material editor, now I can right click on the material and choose Assign Material to Selection. And if you were watching, we saw a little bit of a reaction there on that item, and it now has the new material. If I wanted to, I could drag the output node from the material and drop it on top of that object out in view. You could do that as well. So I'll do another one. This time I'll do another physical material. And we'll double click on that to activate it. And this time we will call this the tray. This is our tray material. For a preset, we'll choose something like, how about matte aluminum? Now for this one, instead of going around and picking all of the individual pieces and parts inside this group, you can do this from the Scene Explorer. So on the upper tier, we're still inside that group. We can select it in list format. So I'm just going to use the Shift key and select everything except for the wood base. And that's a little bit quicker than having to pick all the individual objects out in the view. Once you have those selected, you can right click on the material in the material editor and assign material to selection. Also remember to make sure that is shown in the viewport. And that button is right here. Show shaded material in viewport. Okay, so we'll just do the top one. And when you're done operating inside the group, we'll come back to the group drop down and we'll close it. And we'll also close the material editor. And so now we've got new material added here. We'll switch back to our camera view. And we'll do another test render. So now you can see the differences. Here's our new material applied for the base and for the top tray. So that is how you can add new materials in case the Inventor assembly didn't come with those and there's no way for you to add the materials from Inventor. So you can do it in both places. The main point is only do it once. Either do it in Inventor or do it in Max, but not both. Now I'd also like to show you one more trick for working with the materials so that you can see them in the same manner as Inventor. So I'm going to open the material editor again. Also just going to wipe the canvas clean. But remember, we don't have the Autodesk material library available to us right now. So what you'll do here for this trick is come over to Render Setup. That is the button that's just to the right of the material editor. In the Render Setup, what you'll do is you will change renderers to the Art renderer. This is another one that comes with Autodesk or with 3D Studio Max. That stands for Autodesk Ray Trace Renderer. It's been around for quite a few years. But all we need to do is set that to be the active renderer. We'll close the setup and go back to the material editor. Now we can see the Autodesk material library. So if you wanted to work with this, in the same fashion as you do in Inventor, then just change renderers. Now we can see all of those materials. So if I came down here, maybe I'm going to use some brick for this. I'll just add one to the canvas by double clicking on it. That'll add that material. And now I can apply this material anywhere I want. So I'll do this to the bottom group. So we'll open that one up. Then I'll pick the base. And then over in the material editor, we'll right click and assign material to selection. And then just make sure when you select that you show shaded material in viewport. That way you can see those materials. They're not quite realistic, but it will be close enough so you know that it's working. Now this material is not an Arnold material. So if I hit the render button right now, I will get an error for an unsupported material. So since I switched renderers just to grab a material, now all I have to do is convert the scene one more time. And I'm still inside this group here, so I better close that. And then we'll go back to the rendering drop down and go back to scene converter and just convert the scene again. That's all you have to do. Now you can render. We do have an error. We'll look at that in a second. But as you can see, now we're able to apply a material from the Autodesk library and then just reconvert the scene again. So you could go back and forth as many times as you want, depending on how you're doing your materials. So if you wanted to make sure you're getting an exact match from Inventor, then that's how you can do it. Now let's look at this error real quick. We don't like to see errors, but this is one of those errors that tells us exactly what to do. So we know it's not supported, and it was that wood material, the varnish one that I used, but it's telling me to try enabling Legacy 3D Studio Max support on the System tab in the render settings. So I love errors like this if they tell me how to fix it. So that means we go to Render Setup. The message said go to the System tab, and then check that box right there. Legacy Max Map Support. So when you're using the Arnold renderer, you can do this ahead of time, or you can wait for that error, and that'll remind you to come over to the System tab and then check this box. That way you can use those older materials that have been applied over the years. We'll go ahead and render from here. Now we're getting no errors, and we've got everything converted back to the Arnold renderer. So you actually have three ways that you can apply your materials. You can do it in Inventor, you can do it in Max by adding physical materials, or you can switch renderers and then apply your material and then convert the scene again. So plenty of flexibility with your materials in Max. All right. So now let's look at the quality for a minute. We have been rendering at pretty low quality just to keep things fast. But when we do that, we do have to deal with this graininess or this noise that we're seeing in some of the materials. It's very visible in the metallic materials. So I can't really increase the settings here in the renderer itself, because it would just take too long. But I have done some ahead of time, and that's what I'm going to show you next. Okay, so a quick review, and then we'll show you those other quality settings. On the Max side, your step one is to import your assembly. We want to make sure we're using body objects. If you want your driving animations, you can bring those in as well. Just remember that you can only bring in one at a time. So it's actually better to leave those behind and then animate in Max. The assemblies and the sub-assemblies will be treated as groups when they first come in. I think it's a good idea to ungroup the top level assembly only, leave the sub-assemblies as groups, makes them easier to animate. We use the scene converter to make the materials from Inventor work with the Arnold renderer in Max. We also set up our time configuration up front. And remember, if rotation is one thing that you're animating, make sure you check those pivot points when you're setting up those keys on the timeline. And lastly, make good use of the auto key mode on the timeline and let the software do the work for you. Let it do the interpolation in between your frames and calculate all that behavior for you. All right, so some of the rendering results, the ones you've been seeing here were just out-of-the-box settings that you get from Max when you first install it. Here's the workstation that these were done on. It's an off-the-shelf workstation. However, it does meet the Autodesk hardware requirements. That's important. So if you want good renderings and animations for Max, then it's important to make sure that your workstations meet the hardware requirements from Autodesk. We are using the Arnold renderer these days, and I did 3 different renderings plus an animation, a draft, a medium, and a final. The draft one is the one you've been seeing today, just the out-of-box settings, and here they are. You'll find these settings on the Arnold renderer tab in Render Setup. It took about 13 seconds, which is a good setting when you are just getting things ready and you want to make sure that everything is working. So it will be very fast. The medium settings, this one took a little over a minute and a half, and the settings that I changed were this one right here, the camera AA setting, and the diffuse setting, and the ray depth setting. It didn't increase it by much, so this is something I could live with. It did drastically reduce the noise just by upping these settings here. The diffuse setting is what really helps with noise on your materials. The camera AA setting is a global multiplier, so when you increase the camera AA, that increases all of the other ones that you see in Render Setup. So you want to be careful how high you set this. So between draft and medium, you can see the difference. There's a considerable decrease in the noise with not much increase in the render time. So that's a good thing. Now from medium to the final settings that I did, as you can see here, I increased the camera AA to 10, but I left the diffuse and the ray depth setting for that the same as the medium render. So I just did the global multiplier on this, and this is where the time really started to jump. So from a camera AA of 5 or 6, it doesn't go up much, but it goes up by about a factor of 5 when you hit a camera AA value of 10. So if you think about that when you're rendering, then you multiply your time needed by 5. And that'll help you plan out your process when you do that. So there was draft right there. Medium's got a lot of noise reduction, a little bit of increase in time. Final has a drastic reduction in the noise on the materials. It looks really good, but the time has significantly increased. Now this is really going to matter if you're going to animate and you want to render at a higher quality. So here's the rendering. If we went ahead and exported the animation of all the frames, this one here was done on draft settings, like you saw earlier, and it took about an hour to produce all of those frames. And then you can export that as an AVI file from Max, or you can export the individual frames as images and then use another program to stitch them together into a video, or you could stitch them together in Max as well. So you have some flexibility there. Now the reason I'm showing you this is just so you remember to plan this out before you hit the render button on an animation. If you go too high on your quality, as you can see here, if I use my final settings, this particular animation would have taken 36.5 hours, which is a long time, but if it's what your goal is, that's fine. But this ought to help you gauge how long you'll need. So when someone asks you how long is it going to take to produce, then you can give them a nice estimated figure on turnaround time. All right, and that concludes our presentation today. I'd like to share some of our online resources with you. We do have a YouTube page, and you can find all our recordings for our previous webcasts up there. This one will be available shortly after. Plus, we have plenty of articles on our blog at hagerman.com and even more content on our customer site, so be sure to check that out.
Hey, Brad, I got a couple of questions and one comment there on the last link. That link is not currently ready yet for our customers, but we are planning on rolling that out next month. We had a question. Would it be possible for you to address or at least show possibly how to animate a camera?
Animate a camera.
Just, add another animation. It's like we don't have to have just one or two animations. You can have that animating, plus you can have a camera rotating around it at the same time. Mm-hmm. And then the other thing I wanted to comment too, on the times it takes to render an animation of that length, it really depends on what kind of materials you are rendering, because we've got a lot of reflections going on these materials, and so that adds to your render time. So if it was something that had no reflections whatsoever, the render times would not be nearly that long. Just want to make sure you understand that the types of materials you're using does affect the amount of time it takes to render.
Yeah, good. I'm glad you brought that up, Jordan. Speaking of reflections, there is something I meant to point out. When you first import your assembly that has materials on it, I'm going to go back into the material editor and show you what I mean. Some of the materials, and wood's a great example. See, I did it on the one called base. So I'm going to open up the base material here. This is very important for you to check this once you convert your scene with the scene converter. You want to go into the materials and you want to make sure that the reflections are set accordingly. So what I just did here was I just double clicked on the base material that I added, and I changed the material mode to advanced. When you do that, then you get an extra section here for reflections. Now this is supposed to be a wood material, but Arnold gave it a reflection of 1, which means 100% reflection. That's not right for a wood material. That should be 0. So make sure when you import your assemblies and you run the scene converter, go to your materials and go through each one of them and make sure that the reflections are set accordingly. This one here, we would set to 0. If it's wood, I doubt it's going to reflect at all. Other ones though, like steel, we'll edit that one real quick. Same thing. It has a metalness of 1, which makes sense because it's metal, but it also has a reflection of 1. And a lot of metals don't reflect much, if at all. Reflection of 1, that would be for something like a mirror or something stainless or something chrome, something like that. But other steels like cast iron, they're not going to reflect at all. So make sure that you do go through your materials and check your reflections. For something like this, maybe you'd set it to like 0.1 or maybe less. Just depends on how shiny you want that to look when you render. So that's the other thing, along with what Joyce said, how reflective those materials are. It will increase render time, but you do want to make sure that you go through those, especially on non-metallic materials. That's something that Arnold does. It just sets all the reflections to 1 for all the materials. And so it's up to us to make sure we go and set those accordingly before we render. Okay, so Are there any other questions that haven't been answered from the question panel?
Brett, I'm in the middle of answering this one, and that is how and where do you export the animation? And I was just explaining that you process all of the, you don't export these or render these to an animation file. You render them to individual frames. And once you do that, it automatically puts, like, for example, 001 to 301 behind each of those 300 frames that you're rendering. And then you would open that up into, I think it's the RAM preview, I can't think of the name of it. And then you would, and if you want to just go ahead and show that, where that's at.
Yeah, so in Render Setup, over here, on the Common tab, the default is a single shot, so we would change to active time segment. And then down, we have to scroll down just a little bit. We'll come down to the Render Output section and go to Files. And then we'll give it a name and change the Save As type. Now, you could export straight to an AVI file. Personally, I use PNG and render out each frame. That way, if I see something I need to fix and it's only in one frame, then all you have to do is re-render that frame versus have to re-render the entire AVI file. But you could do it. I just don't recommend it because it takes if I'm doing that final render, it's going to be 36 hours. Or if I have one frame that maybe it's too reflective or something, I only have to render out one frame, which would take 7 minutes. And then you plug that back in and we stitch it back together.
Yeah, it's definitely not recommended to export or save as an AVI file. One good example, which has happened to me years and many decades ago, basically, you're rendering that. It takes hours to do. You're on the last frame and your computer crashes, and you have to do the whole thing over again. Yeah.
So we don't advise that. And what I did for the render that I put into the slideshow, here are the slides. So here's the 300 images, right? I did this ahead of time. So then to do it from here, we'll go back to the rendering menu and come down to the RAM player. And we got two channels here, so if we're doing a comparison, then we could load two sets of files. I'll go to Open Channel A, and then we'll just go into this folder here and open the first image, which is right here. Once we do that, then the RAM player will load the rest. And this will take a few seconds. But as you can see, as it's loading those, it's already playing, so we can watch it. So we would bring these in to the RAM player. And it has its own playback tools, if you wanted to see it. And then you can save it. And here is where you would change your format to AVI and export the final one. And there's the one I did prior to the webcast. So I came into the RAM player, loaded all the images, came in here, and I named it Spinner, changed the type to AVI, and then it took a matter of 30 or 40 seconds to produce the AVI. You could also use a third-party program if you want to bring those images together. You could use Windows Media Player, you could use Camtasia, whatever your desire is there for post-processing. So you have some options there. Now the previous question about the camera, animating the camera, that's the same method as we would animate anything else. So if I switch to multiple views here, let's say if I were to animate the camera, and maybe I just wanted it to move a little bit while it's spinning. So first thing I'll do is make sure I'm on frame 0 on the slider. Again, we'll turn on auto key. I'll pick the camera, turn on move, and here I'll just move it like so. I could rotate it, make it spin 360 degrees if I wanted to. Here, I'll just move it a little bit. And actually, I should move the slider bar before I do that. So let me undo that. Take the slider bar out to 300. Or maybe I'll take it halfway. So let's take it out to frame 150. So the movement will take place from frame 0 to frame 150. It's just going to move over, but it's still staring at the display there. And then turn off the auto key. We'll set that back and see what happens. So there the camera is animated as well. So you can animate the camera the same as anything else. You just make sure you pick on the right aspects of the camera before you turn on auto key. So if you want to animate the camera itself, make sure you pick on that object, because the camera has two objects. It has the camera and it has the target. So just make sure that you choose the appropriate object that you want to move or rotate. And there are other ways to rotate it. We can put this on a path if it's more complex. Maybe it's more spline in nature. Those are the types of things that we address when we conduct training for 3D Studio Max and more in-depth animations. What we're doing here is quite basic, but very simple movement on the cameras can still make your final result really pop. And Joy, I'm not sure how many more questions there are.
I'm pretty sure that was it. We did have one question about exporting constraints, and you can do driving constraints. You can export those, and I sent there are links to that. You can on Autodesk Knowledge Network if you wanted to see those. But I think that was for the most part it.
Yeah, you can. It's just that you can only import one driving constraint at a time.
Yeah.
Not an entire animation from Inventor. So.
And then one other comment, and I'll just put that out there for you so I won't forget it later. We had one viewer at least say they'd like to see exploded view animations. So how you could do an exploded view within Max.
Okay.
Maybe for a future webcast.
Yes, we could, in a future webcast, we could do one like that. I chose this topic for doing rotation because I had not seen one done on rotating and having to fix your pivot points. So that's why I picked this one. So that is possible. So stay tuned for more, or we could meet in a separate conversation. Those types of things we do address when we conduct our training classes.
Okay, I think that's really it that I've got for you.
All right. And let's see, it looks like everything's been answered up to this point. So, well, everyone that's still on the line, thanks for attending. We hope to see you next time.
Yes, thanks. Thanks, everyone. Have a great day.